In this video we're going to continue our little journey with sketching of exponential functions. There has been an earlier video or two on, so be sure you've seen them before this one. Just going back to those videos, we know that this is a logarithmic function we see here of y. We can see that it has a base raised to a power, and the base is base 10, so that gives us an idea of how it will behave. It'll climb as we go from left to right, and we have a dilation factor of 2 there, which would make it stretch vertically, and a translation vertically down by 4. So we need to factor those in. So those parameters A and D are there. No other parameters are significant in this. So our task here is to sketch this with reasoning, with justification, and so I'm going to put that in because some students try and ditch that and they wind up in all sorts of trouble. Okay, it's got to have justification. That's the point of it. Otherwise, you can just do this on a calculator, but it doesn't show what you know, and that's what teachers are often after. What do you know? What's your understanding? And the justification not only supports your work, but it also shows the person who's looking at your learning, shows them what you know. The other thing we need to look at is the equation of the asymptote. And the intercepts. I use the plural there. The axis intercepts. So where does it cut the x and y axes? Now just thinking, we know that if it was just the base function y equals 10 to the x, we know that the x-axis would be a horizontal asymptote. And remember, that's got the equation y equals 0. That's a 0. There we go. So this one's been moved down by 4. So we can explain that the asymptote, or the horizontal asymptote, so since d equals -4, the horizontal asymptote will be y equals -4. Or another way of saying is, we talk about the behavior of the graph. As x approaches, now let's have a look. If we've got the graph of y equals 10 to the x there in purple, we can see that as the graph approaches negative infinity, so as you see my cursor move to the left, it's approaching that asymptote. We've seen in earlier videos that sort of behavior. So if we move it down, that behavior as x approaches negative infinity becomes, as you can see down the bottom of the screen, x approaches -4. Sorry, I should say y approaches -4. So you can see that down there. So it doesn't actually hit that -4, but it approaches it more and more and more. That's that asymptotic behavior we've looked at in previous video. So we write, as x approaches negative infinity, y approaches -4 from above. Okay, now things can approach from above or below. On this diagram, this graph here, it's approaching it from above. If we zoom in and have a closer look, alright, you can see that if you look at where my cursor is, it's approaching it as we go towards negative infinity to the left. It's approaching from above it. Okay, if it was approaching from below it, it would be tracking like my cursor is suggesting there, as you can hopefully see in the video. Now for the intercepts, so let's look at the y-intercept first. The y-intercept is when x equals 0, and we can just substitute that into the equation, so that'll make the x equal to 0. So we have y equals 2 by 10 to the 0 minus 4. 10 to the 0 is 1. Anything to the power 0 is 1, so that's 2 by 1 is 2. 2 minus 4, which is negative 2. X-intercept, lastly, is when y equals 0. So 0 equals 2 times 10 to the x minus 4. So we have add 4 and then divided by 2. Sorry, that's an x there. So doing the 2 steps to save some time, add 4 and then divide by 2. So we have 2 here. 2 equals 10 to the x. Now this is where little help from logarithms comes in. Hopefully you've watched the preceding videos in the correct order. So changing that equation there, or that statement there, we have x equals log of 2 to base 10. We'd use our calculator for that. So that approximately equals 0.301 if we go to 3 decimal places. Now you're welcome to write, just if you don't want a decimal approximation, you're welcome to leave your answer in log form, because that's the exact value. This 0.301 is an approximation which we might need when we graph it, and that's what we're going to do now. So switching over to a different color, and we've got some points here. So we have the x-intercept, we have the y-intercept, and we have the equation for the asymptote. And so if we look at our graph, which I've drawn over half of it already, we've got -1, -2, -3, -4. We've got our asymptote there, so let's draw that in. Okay, so I put in the x-intercept there at 0.3, it's rough, and the y-intercept at -2, which is going to be there. And now we can draw our line in. So here we go. It's got to go through those 2 points and then approach. And it will look different depending on what scale you've used. And so on. So it depends on what scale your x and y axes. You could spread out the increments here and make it a little bit easier to sketch if you like. So whenever you sketch, remember to use justification.